Read the zygoma case, zygoma logical guides, which will looks like this. Let's take this case as an example. I will copy this case. I will go here and create a copy. Just rename this case. How I should start to work with this case. I start with AI Assistant because AI Assistant is really help me with the segmentation. But AI segmentation is usually not enough for this type of cases because in zygoma case, we need to see the eyes here. And AI segmentation don't give us enough space, but the bone consistent is much better with AI. That's why I will go to AI and let's see what we have here. Actually, it's a little bit too much. I just need the maxilla jaw, but I have the parts of the scalp here. And what is the mandible? You see the mandible is segmented like this. This is also a mistake. I turn off my mandible and I just keep my maxilla. I click import review data. The another parts I already prepare patient coordinate system. Yes, we can check it. Panoramic curve. And nerve canals, actually, I don't need. And then we click import review data. There are no segmentation. What we have here in AI models, as I told you, this is too much, but how we can adjust it? Just click with the right mouse button and click Edit Mesh. And right now I can click on Part Detection. Detect all parts, and now I can see selected parts, and I delete all parts but keep selected. Then I click on Apply. So now my AI model is modified. So then I go to segmentation and I will create the new segmentation with the maxilla jaw. I select the new empty layer and change my density. I think this will be fine. What I need to do next, I will take my scissors and cut it like this. And now try to segment. Now you see that we have some connection with the mandible. So I deselect this and let's see what happens here. One more scissors. And let's try again. Yes, now it's much better. Now we have this part segmented. and close this model. Okay, now we have Joe here as segmented, and we need to create from the bone actually STL object. And why I did AI segmentation? Yes, you can create the different level of segmentation, but usually it takes a lot of time. And with AI, it's much faster and it's much easy. That's why I like to use AI segmentation for this purpose. And then, because I need a little bit more bone, I will merge AI segmentation and this segmentation. How to do that? My segmentation for matching, I can convert into 3D model. And here I have some presets, but I will show you how I create my preset. If you click on edit, you see the different settings, and if you click new, there will be new preset. Let's see, let's click on new and go to the settings. And resolution, I think half it's an okay. Noise reduction, yes. Reduction, medium, I think. Filter large objects and optimize, I think, on. Yes. And then we click apply. Then we click down and select. Now we have this bone. This has been segmented. I can actually open my segmentation with the right mouse button and mesh editor. And here I can combine with maxilla like this. Now I can click on merge mesh, apply operation. And right now you can see the perfect bond. Click on apply. Turn off your segmentation. And right now you can work with this ball. Let's change the visibility. Maybe click on visualization. And here you can change the color. We have some color presets here. For example, I will select the bone here and click OK. Now it's much better. And after that, we are almost ready to create the surgical guide. Because for zygoma, we need to create the sleeve as well. But which kind of sleeve we will use? For example, if we have drill as a 5 millimeter diameter, if we want to use the 5 millimeter diameter of drilling different instruments, we wanted to create the sleeve with the whole 5 millimeter, and we would like to print this surgical guide from the metal, so we need to create like a sleeveless sleeve. To do that, I go to the extras and I click edit custom sleeve. Here I need to click new, set terms and conditions, click OK, and now I need to show outer diameter. It doesn't matter which inner diameter we have, because inner diameter will not create it here, because we just create a sleeveless sleeve. I just need to care about outer diameter. 5 millimeter as we decide, and the length of the sleeve. I think also 5 millimeter is enough, but maybe just create a little bit longer to have cylinder. Just for example, 7 mm. Then we go next. Here we need to show which distance from the implant we need to have. Maybe let's go back and create it a little bit bigger. Just like this. And distance from the crystal level, I used to select this one. I will put 0 here. Maybe you can create different presets like 0, 5, or maybe 3, just for example. Then we go next, click on it. Here we don't need to select anything, we just click on OK. And now go next. And click on Finish. Then click Close. And we will create the surgical guide for the left patient side. This is the right side for us. We plan our Straumann zygoma implant, zygoma flat, and zygoma round. And now I need to put the sleeves here. I go to the sleeves, go to the custom, and if we see here, training zygoma, and different position of the sleeve as we created. And why we do that? Actually, if we put 0, you see that intersect the bone. It's okay. And how far it is? Is it go too far or maybe less? Maybe I will put it like this. Just to put out of the bone to have this cylinder a little bit more fun. Then go to the next 16. The same sleeve. Training zygoma. Oh no, sorry, that was incorrect. Sixteen, 22, 26, and 22. Here you can see that the sleeve finish in the bone area. We need to put it a little bit out. Maybe like this. That's why I created different distance. We don't have particular protocol for the instruments, and we have this just for understanding where we'll finish our surgical guide, where we will have material. Like this, I like this position. After that, I need to go to the next step, and the next step will be creating of the surgical guides. The first surgical guide will be the helper surgical guide. Go to the step number 7 and select as a base model our segmentation. And then we click next. And if we create insertion view like this, it will not be correct. We need to put it a little bit like this. Then we go next. This sleeve was incorrect. And right now we need to proceed to the next step. So I can actually use this sleeve just for orientation, or I don't need them. I select some teeth area here. Maybe I can put something really, really big. and next again. Now we have surgical guide looks like this. Save this. Click next and next again. And apply. After that, I have this raw surgical guide. I need to cut maybe this part a little bit. Let's see. Convert this surgical guide into 3D model and open now this surgical guide in Edit Mesh. Now we need to adjust it. First of all, I go to Repair Mesh and see is it okay or not. Maybe system repair some parts. And after that, I don't care about the bottom side of the surgical guide because I will use the upper side. And the bottom side, the system will generate again automatically, and it will be suited for the final restoration as best as possible. So right now I go to wax knife and select local smoothing. I like the local smoothing A. Then I smooth this part. Then I would like to cut also this part. Yes, I can smooth it, or I can use cutting tools as, for example, eraser, or draw margin line is also good for this purpose. And after that, when we close the margin line, I can select Cut, Mesh Along Margin Line and select this object. And now I can select and close holes. Okay, now it's better. Then again, local smoothing. B, small gently. And for example, here, if I want to make this part a little bit bigger, I can use the box knife and design some parts here. And after that, I save this object. I don't need to save as a copy. I just click apply. Right now we have our object better. If you close this one, you can see this row STL. And for the next steps, we need to see cylinders of our surgical, of our implants. And for this, I switch off this part and I'm looking for the length of the implant, how much I would like to extract. Where is the start of my implant? So it's here. For example, I go here and select the distance, and from here to here, I have 35 and 2. Okay. Also, how big I would like to create window here. For example, I would like to open it here. I go to the distance. You can measure more precise. Just show you this as an example. You can align with the cross-section view, of course. And if we go to cross-section, maybe it makes sense from here to here. And this one I will delete. So right now we have 21 and 7 and 35 and 2. And the next step, we need to create cylinders as we will subtract from the next surgical guide. And for this, I need to have to create an STL file. I need to go to the plan and virtual planing export, or I like to use this icon because this is a shortcut to virtual planing export. Then I select STL file, I go next, and I need to select insert implants analogs. Here I need to select any STL file, doesn't matter which one. For example, I will select my template. Then I go next, bigger, and here I have cylinder. So we create in the guide for the second quadrant. Here I don't need implant position, I need, abutment position, I need implant position. Here I create new implant analog, and if you remember which lengths we have, this is 32. So here we will do like 33. For example, there will be 33. And this part you need to make higher, because this part will be subtract uh, from the sleeve. Make it higher, and okay. Now we have first one, and for the second one there was 21, sorry. Make 22. Okay. And then also the upper part will make a little bit bigger. That's enough. Then we click OK. Here I need to select Integrate to the model analysis. Also Integrate. Then we go Next. Next again. And next again. And very important here to select the coordinate system. And it's better to select patient coordinate system here and in a multi-file export. Then we go to the export planning. We select the folder, go to downloads, create new folder, and select this folder. And then close and close again. And right now we need to upload these cylinders in the system. You know that we can upload from the step number 4, but if we select step number 4, we cannot change position of this implant, of these objects, and we need to align with something, but we have option to make it also easily, and we will have a possibility to move this object as well. So right now I go to the small area here, and I go to 3D model. And I select the folder. And here you have different names of the object, and actually our object, this is analog. You can see it here. Just select 2 of them and then click open. And now your analog is automatically here. You see that the position of them is all right. If you would like to change a little bit position of them, it's also possible. But you need to be careful that you are not move from you don't move them from the axis of the implant. You can do this, for example, with the fine alignment. And if you go to the fine alignment, you can adjust the position, but the axis could be different. You need to find the correct way of them, and it's quite complicated. So I don't like to do that. That's why it's better to measure before and then to do the next steps. So reset position and rotation, and your analog will be in the same position as planned before. And right now we go to guide design. You select your model, go next, select insertion view again, and here I deselect this sleeve. It depends which materials you will use. If you will print your surgical guide from the metal, sinterize it from the metal, you can make this really, really thin. For example, we have the wall, the diameter is 5 millimeter, right? And we would like to have wall maybe 2 millimeter of the sleeve. In this case, I can make it 7. Maybe let's make it a little bit wider. Let's make 8. And then the length of the sleeve, I need to make it bigger. I don't care if my sleeve intersect the bone. I actually can make it as big as possible, but the biggest is 20. Then here maybe I need to have some area also. And then I go next. Now we have surgical guide, which looks like this. And we go to add object and we select our first surgical guide as we adopt this one. Now they are perfectly connected. You don't need to select here anything more. And the next object, you select here template analog. One and one more. You see that selected objects, they are gray and you cannot select them anymore. So now you select the analogs of the implant. But here, if we merge our template surgical guide, but with analog, we need to select subtract. And in the offset, it's better to select 0 offset. And the overheating, if you select don't remove overheating, there will be just a solid STL file and the file will be just subtract from this. If you remove overheating in insertion direction, the system will cut everything from the bottom part of surgical guide in insertion direction. But in our case, we need to remove overheating in opposite direction. So we need to delete overhang in opposite direction of insertion. I click OK here. And the next one, subtract, offset 0, remove overhand in opposite insertion direction, click OK, and then go next. Now you can see your surgical guide. You can engrave rotation markers. Click next. And apply. And now your surgical guide is finished. And if you would like to add some screws for fixation, something like this, it's better maybe to create the first surgical guide like this, convert into 3D model, and after that add some screws and the sleeves for these screws. I can also show you how to do that. For example, I convert it into 3D model and I go to add screw, go to the implant, and we have instrument micro screws. You can see diameter of the screws. For example, I will select 8 millimeters. Which diameter we have? 1.2. Okay. How much screw we want to place? Maybe 3. And after that, we are going to place our screws. And this one as well. Let's place it over here. And maybe one more screw. Place here. Here is sinus. Maybe here. No, actually, I don't like this screw. I will remove it. Now we have our screws, and we need to create the sleeves for the screw. We go to the extras and click Edit Custom Sleeve System. Here I need to create new sleeve system, and my inner diameter is 1.2 millimeters. So my diameter of the screw. In this case, I will create diameter of the sleeves 1.2 or even 1.3 millimeters. The length is actually not too important. Let's make them short. Maybe 2 millimeter. 2 millimeter length. And then we go next. Here we need to select distance, complete length, or distance of the top of the implant, distance of the crystal level. In this implant, we can see that the crystal level, this is actually the top of the sleeve. So I will select, I think, the crystal level of the implant. And the position here, I will select 0. Because my sleeve couldn't be created here. My sleeve only can create in the top. And I go next. And then I click Add. Here I don't need to adjust anything. Maybe I can No, I don't need to adjust this. Just click on OK and then click next. Let's call it section screw and finish. And then close. So right now, if I select the sleeve for this, edit custom sleeve, and I select fixation screw. And right now you can see the sleeve is here. And we need to put the sleeve for the other one. This. Yes, okay. Actually, that will be your direction of the implant. So this is 2 mm. Here is a little bit tricky. You need to understand that if you put the sleeve here, your screw will be 2 mm less inside. For example, I can put it like this. And here as well. And now we need to create the surgical guide for the sleeves. We go to the surgical guide design and we create new surgical guide. We select insertion view again. We go next. And I deselect my sleeves here. I just will keep these small sleeves, but I need to increase little bit the height of the sleeve. And I don't like that system will create me like a bar here. That's why I will select the tools and place it here. Then I go next. And right now you can actually add object and now select your surgical guide 2 as an object. And then next. And apply. So, and now you have everything well designed. You have, let me select, you have surgical guide with the hole for zygoma instruments, and you also have the screw fixations. You can adjust the surgical guide depending your anatomic situation. You can modify these parts, and because you remember that we just little bit the bottom part, but if I select this part here, you can see that my surgical guide fit really well with the bone. Nothing going inside of the bone because the reference was our last position. And that was the way how to create zygoma surgical guides.